this was inspired by the 6 degrees of separation, but it's more looking at the average degree of separation in terms of predicting it with the network. So the Facebook study found that the average degree of separation of their users was about 4.57, whereas this model outputted 12.7, about 178% error. For all the data points I tested against the manual program, it was 100% accurate. It was the same average degree of separation. This is the proof that I have so far. Network model does not interconnect the population enough, so I'm going to alter it so that it does, and retest it and recreate an equation. And then once an accurate network model has been created, then I'll use that in distribution and look at how I can increase the efficiency of distribution using this knowledge about how connected the population is and starting distribution in more connected areas, dispersal rate increase.
So you said, okay, this model isn't going to be accurate enough, so what are you going to change in this model?
So this network model right now does not connect the population enough because the average degree of separation was far greater than the average degree of separation in the real world that the Facebook study showed.
So what are you changing in your new
So there's 2 different approaches I'm thinking right now. One is that I change into, I look at nodes on a grid, and I connect the nodes on a probability, and that probability would be dependent on how close the nodes are to each other. So if nodes are closer to each other, there's a higher likelihood that they're going to be connected, which would represent that grouping effect. And then there would be a couple long-range connections that would connect those groups of different areas, and hopefully that would do a better job in this network model.
What type of modeling do they use?
Well, so the first, a bit of history. So in 1929, Friedrich created the idea of the 6 degrees of separation. And the first kind of proof of it was in the 1960s. Stanley Milgram conducted a small world experiment. And so he gave packages to people in Nebraska and Kansas and asked them to send it to a target person in Boston under the condition they could only send it to somebody they knew on a first-name basis. And he found that it was approximately, of the packages that arrived in Boston, it took about 6 times of them being sent before they arrived, which was the first kind of proof. And then in 2001, Duncan Watts did the same kind of thing, but with mass emails, and he found approximately the same results. As the population grew larger, basically to look at it, you have to look at every possible pair. So if there's 2 people, it would only be 1 pair to check. 3 people, then there'd be 3 pairs to check, and it gets exponentially larger as the population grows.
Did you consider any other ways of trying to approximate the...
Well, so the mathematical analysis is not an approximation. The mathematical equation does represent, or once proven, will represent exactly what the average degree of separation is. I could look at it as a sum of the number of times the subgraph of size S occurs times the sum of degrees of separation of that subgraph, and then look at that for all the subgraphs